In this video, I want to have a look at investing money where there's regular installments being made. So that could be something like superannuation. So when you've got a superannuation account, you don't touch it usually, you don't take any money out, but every month or every fortnight, whatever it is, how often you get paid, there are regular installments being made into that account. So what that means is that each installment, each amount of money that's being put in there is going to be earning interest for a different amount of time. So the first lot of money that's going in there is going to be earning interest for a really long time compared to one of the more recent investments or installments. So the way we solve problems that involve regular installments is to create a geometric series looking at each of the investments and then find the sum of that, to find the total amount of that investment at the end of the time period. So let's work through this example. So we've got Kate's parents invest $500 in her name on the day that she's born. Every year on her birthday, they also add or invest another $500 up to and including on her 17th birthday. On her 18th birthday, Kate withdraws all of the money. If the investment was earning interest at 6% per annum compounded annually, we want to calculate the value of the whole investment at the end of the 18 years, correct to the nearest dollar. So we're finding out how much Kate's withdrawing on her 18th birthday. So let's have a think about that first installment. So this is the $500 that they're putting in on the day that their daughter's born. So we're going to have $500 times, and this is going to be earning compound interest. So it's going to be 500 times 1 plus 0.06, because it was 6% per annum. And this first installment, because it was put in there on the day that she was born and it's going to be there until her 18th birthday, it's going to be in there for 18 time periods, 18 years. Let's think about the second installment now. So this is the $500 that's invested on her first birthday. So it's still earning compound interest at that same 6%, but this time it's only going to be in there for 17 years. Now we could do this for the third, the fourth, the fifth, all the way down till the 18th installment, which happened on her 17th birthday. And that was the 18th installment, even though it's only her 17th birthday, because the first installment happened on the day she was born, so her 0th birthday, if you like. But we're not going to write them all out. Instead, we're just going to go dot, dot, dot. Let's have a look at the last installment. Oops, press the button. Installment. So this installment's happening on her 17th birthday. So that would be our 500, not 5,000, times 1 point plus 0.06 to the power of just 1. Now we could also simplify all of these down if we add those numbers that are in the brackets. So let's have 500 times 1.06, 0, to the 18. This one's 500 times 1.06 to the 17, and it goes all the way down until we get to 500 times 1.06 to the power of 1, because that last one's only in there for 1 year. Now, if we want to find the total of all of those things, we're going to find the total of all those 18 terms, we're going to add them all up. So I'm going to start at the most recent one and write them backwards. So we have 500 times 1.06 to the 1, plus if we do the one that was invested on her 16th birthday, we'd have 1.06 to the 2, plus all the way up to 500 times 1.06 to the 18. Now, when we write it like this, we should be able to see that this is a geometric series, because each time we're multiplying by that 1.06 to increase the power until we get up to that 18. So that means it's geometric series. Our first term is 500 times 1.06. Our rate, sorry, no, not our rate, our common ratio, what we're multiplying by each time is 1.06. And our n, our number of terms, is our 18. So because we're trying to add all these terms together, we're going to find the sum of the first 18 terms. So we're going to use the sum of the geometric series formula. So we're going to have 500 times 1.06, that's our a, outside of r, so 1.06 to the power of n, so 18 minus 1, over 1.06 minus 1. Now, if we put all of that in your calculator and we round to the nearest dollar, we would end up with $16,380. So that is the total amount in the account on her 18th birthday.